So, we're ready to kickstart the afternoon sessions. The panel is Lower Emissions, Lower Costs, the business case for energy efficiency devices. Now, the potential for energy efficiency technologies is well recognized, but adoption remains uneven. The session that will start in a bit will examine the commercial and operational realities of these solutions. Please, can I get your attention? Thank you. So the session will examine the commercial and operational realities of such solutions, what is actually delivering value in practice, what challenges persist, and how organizations can scale implementation to achieve both emission reduction and also cost efficiency. Joining us as a moderator for the session will be John Lane, Head of Sustainability at RightShip, and we will also be joined by the following panelists: Chris Hughes, Director of and Decarbonization Lead of Ocean Transportation at Cargill; George Terikiadis, Regional Manager for Southeast Europe at DNV; Panos Kourkountis, Chairman of Martechma and Technical Director of Sea Traders; Jessica Doyle, Global Sales Director of Shipping at Jotun; Ariana Psomas, Global Marine Segment Director at PPG, correct? And Vasilios Tsarsitalidis, Energy Saving Technologies at Irma First. Thank you. Please help me welcome them all on stage.
Good afternoon, everybody, and I hope you had a good lunch. So I'm John, I head up the sustainability team here at RightShip, and I've got a very experienced and mixed panel to talk through this topic today of lower emissions, lower costs, the business case for energy efficiency devices. But I think with these panels, it's always good to try and give a bit of context as to why it's important to look at energy efficiency, not just from a lower emissions point of view, but from a lower cost point of view. So if we look at the decarbonisation journey that we're on, we have a target of trying to keep global heating below 2 degrees by 2050, with a stretch target of 1.5 degrees. And why that's important is that everybody always seems to focus on that 2050 timeframe. But what's really important is the cumulative impact of the emissions that we release up to that point, with the interim targets of 2030, 2040 and 2050. And if we look at 2025, for example, we saw that we had between 40 and 42 gigatons of CO2 emissions released globally. And we know that shipping makes up about 3% of that. If we look through just to 2030, so the next 5 years or so, we have a carbon budget of about 110 to 130 gigatons and at 1.5 degrees. And if we want it to be 2 degrees, it's about 200 gigatons. So there's not a lot of room to play with. Policy alignment's not quite there yet. Things are quite regional at the moment. You know, ideally we get to a point where it's clarity on future fuels, but before we get to that point, we can't wait to take action. It's about those cumulative emissions that we take action against now. And we have this opportunity to learn by doing over the next few years before we transition to that future fuel world where those fuels are less energy dense and where every molecule saved really counts. So there's a lot of opportunity over the next few years, and that's what we're going to talk about. What's delivering value in practice now? What challenges persist in the uptake of ESTs? And how can ESTs scale further? And I'll start with Chris from Cargill. Chris, what ESTs are delivering repeatable, bankable value in practice currently from a fuel and emissions perspective?
Thanks, John. Okay, I'll start with the kind of the usual caveat that every ship type, I think, and every ship different operations means that there's different solutions that work for it. But for us today, I think on the hardware side, it's the usual suspects. Things like propeller ducts, VFDs, better anti-foul coatings we think is a no-brainer. I think these really kind of work and pay for themselves today. But as an operator of dry bulk vessels, a lot of our focus today is on operating efficiency. So rather than just on rather than the hardware, what can we do kind of on the operations and software side of things? So that's voyage optimization. So all our voyages, we do weather routing and speed optimization with Zero North. Biofouling again. So beyond just the paints, how can we, the paints, good anti-foul paints tend to slow down fouling. They don't stop it, so we still need to clean the vessels. So how can we be smarter about cleaning vessels? That's things like new robots, better internal processes, trying to be more predictive rather than reactive. And I'd say the last one that we're focused on as well is data. So I really look at data like another energy-saving technology. If we get better data, we save fuel. So we look at it through that lens.
Excellent. So a mix of solutions and the right solution for the right segment and vessel type. And Jess, if I can come to you, in terms of what are the benefits of being derived from energy-saving technologies which don't get the limelight that GHG and fuel seem to get?
Thank you, John, and thank you for having us here. Much appreciated. And thank you for the paint plug, Chris. Much appreciated. So decarbonisation, obviously, it's a very well-covered topic and gets a lot of airtime, rightly so. But one of the elements which is very close to our heart at Jotun, obviously, is protecting biodiversity as well. And it's obviously linked to keeping your hull clean, so there's obvious co-benefits of reducing fuel consumption. But in terms of protecting biodiversity, it means different things to different people. So for a paint company, it means reducing the risk of transmigration of invasive species. And that sphere was taken by ballast water treatment for a long time. But actually, studies have shown that up to 70% of bioinvasions come from the hull of a ship. So incredibly important to keep your hull clean. And it's good that this is getting more focus and attention. But this isn't being driven from a positive aspect of the co-benefit of reducing fuel consumption. It's being driven by port regulations. And the word fragmented has been used quite a lot today already. Lots of different port restrictions, Australia, New Zealand, incredibly tough, now Brazil as well. So it's not easy for ship owners to make decisions when they don't always know what ports they're going to be calling at, and it's a very fragmented approach.
Ariana, can I pass that to you as well?
Thank you, John. Thank you for the very interesting question. And it is indeed the greenhouse gas, all the benefits of the fouling control coatings are not only the emission savings, it is also biodiversity, protection of the biodiversity, which is something that also the IMO biofouling guidelines have called as a significant risk, and that ship owners need to make sure that they take control of the operational risk management in terms of hull control. Now, for biodiversity, one of the most powerful tools is, of course, the fouling control coatings. And there are two types of fouling control coatings. There are the traditional biocidal containing, which are actually a double-edged sword, meaning that while they are effective in protecting the transfer of invasive species, at the same time they release biocides into the ocean, which actually means that they may also harm non-target organisms. They may increase the resistance of some organisms and actually harm biodiversity from a different angle. Now in PPG we're very much focused in protecting the biodiversity, the marine life and sustainability, and our primarily focus is to develop anti-foulings that are biocide free, so without the release of harmful substances. And those fouling control coatings without biocides are working based on surface engineering technology that actually creates surface that is ultra smooth and does not allow the attachment of fouling organisms, and at the same time also creates very low friction, so less drag, and has the environmental benefits. So this is our focus, so double benefit as well for the environment, for the ship owners, and for the marine life, also emissions, but also biodiversity.
So there's a number of technologies that have co-benefits beyond the emissions and fuel saving side that can be part of the business case for the solutions. If I move over to you, Panos, Vasilios and George, what kind of trends are you seeing in terms of energy-saving devices and equipment? So historically, the traditional hydrodynamic modifications are there, but are you seeing any new things come in over the last 5 years in terms of technologies? If I start with you, Panos.
Look, for the new buildings, actually, you can change the whole ship, the whole concept of the ship, actually, and make the optimization based on consumption and on voyage with low emissions. On existing ships, according to the ship type, size, and also the operating profile, then you have different solutions, so you can't mention one. If you have a specific route, probably even the devices like sails, and or if you have a ship with is operating in shallow waters, air lubrication could be a solution. For other ships it is not. Someone has to take it specifically for the type of ship and to find out which of the existing technologies work out. What is important is actually to realize that to be stuck with the actual benefits that we may have with the present technologies. There are hundreds of reports and studies around. Half of the emissions can be reduced today without any infrastructure, without any major investment, just by applying a limitation of the emissions. I mean that if we are focused on the emission, then there are a number of solutions that the ship can apply to reduce. Operational measures is one of them, but also an energy-saving device. The latest study was published by the World Bank Association, and it is actually questioning why we do not immediately apply this kind of regulations that will promote all the available means that we have today, and we are looking for expensive infrastructure for the future.
And we'll look at some barriers shortly, but George, if you've got any examples of the type of technology trends that you're seeing over the last 5 years.
Yeah, thank you. I have to agree with Panos, and continuing to what he said, definitely having energy-saving devices and measures that reduce the fuel consumption, it's the quickest and established path for decarbonization, at least today. Now, for different measures that we see that are coming up from different studies we've done and that we've seen from a report that we published last year, we've seen that more and more, shall I say, more expensive and bigger technologies are picking up. However, they're not so easy to penetrate and to get, let's say, accepted and invested in by everyone. There are a lot of established methods and technologies that are used and are being used. Sometimes some companies are using more than others. But the new things that are coming in, let's say big sails, for example, because like Panos said, it's not one thing fits everywhere and fits every ship and every route. It's a little bit, we see that many ship owners, ship managers, ship operators are finding it more difficult to see the actual benefit, and they're more hesitant. So the more and more these are used and they're installed, there is more data accumulated. There are pros and cons appearing, and so an investment can be justified, because otherwise it's very difficult. And one barrier is, like Panos said, you cannot apply one thing everywhere.
And Vasilios, the same to you.
Yes, thank you. So we have to keep in mind that we're talking about a very conservative industry. So everybody wants to be sure about what they get and want to have a serious improvement, but not very risky. So from our side, okay, we enjoy a lot of trust from our clients, but if we don't talk about both cap fins or ducts, which are the easy solution that everybody does, and they marginally increase also the value of the vessel, the bigger investments are very risky, and so practically almost nobody talks about them. So I think the issue here is that we need to both be able to show and prove that systems work, and also make it more clear how they cooperate and how they are practically one system that works together. So we need to see how everything cooperates and how we get to one improvement, and not looking at it piecewise and trying to get 1% from here, 2% from there. It doesn't work like that.
So it sounds like budgets being prioritized to the traditional investments where the data's there,
Yes,
and
of
like
course.
people have the confidence in the ROI. So how is that sort of bridge sort of navigated in terms of trying to get confidence in the new technology? What kind of data points and evidence are you seeing that's needed, George, in terms of the new ESDs like wind assisted propulsion?
You mean how we can be convinced to... We have a problem that we have to, I think, mention it, is that in order to go and make an investment, you have to know what's the return on your investment and to know how it pays back, what's the benefit that you get.
Yeah.
Today, unfortunately, although naval architecture has been around for centuries, we cannot agree, the different stakeholders, I mean, in the industry, how we measure, not that we don't have methods, but to agree on the specific way that we measure in order to see what's the benefit, to agree on the benefit, and then agree on the rest. So that is one barrier. And that creates a problem, because when somebody presents a solution and somebody wants to apply it, sometimes they're not in agreement of what's the actual benefit.
And how is it working from a charter and a ship owner point of view, Chris? Is there some systems in place where there's these bigger investments and there's a bit of uncertainty on the return on investment? Is there a share of the upfront cost and the downstream saving systems that's in place that can work?
Yeah, good question. So I think, following on from what you said, you're right. I think there's a whole lot of uncertainty about what return you get from a lot of these technologies, and wind's a great one. I think we thought about this for a long time, and the approach we took is you've just got to take action. So we've now got 3 ships on the water with 3 different wind technologies, and we just learned so much from doing that. So we worked with DNV to quantify the savings for one ship. We worked with LR to quantify the savings on another one. And we've got ourselves we're doing our homework. So we've got ourselves in the position now that, luckily through that experience, that data, we are quite confident on, if we put wind propulsion on more of our ships, how much fuel is it going to save, how much emissions is it going to save, and that type of thing. So I think you just got to do it. And then what we try and do is kind of collaborate as well. So this week we've joined the MERC, the Maritime Emission Reduction Centre here in Athens, and for exactly that reason. So we're going to be kind of collaborating with 5 different Greek ship owners in that, and to kind of work on this, share experience, share data, share resources to try and, okay, we can try one thing, someone else can try one thing, and we kind of share that. And then collectively, we can kind of work out what technologies work today, what are the gaps, and how do we scale it. On your question about sharing, yeah, I think like this year, last year we did 10 retrofit projects where we upgraded, where we retrofitted ESTs together with the owners, so we share the cost and the benefits with the owners on those. The 3 wind propulsion projects, again, each one of those we had a sharing mechanism, a contractual mechanism to share risk and reward. I think it was interesting, this gets spoken about a lot, I think, this kind of split incentives. On those projects, that wasn't one of the biggest barriers. We did it a different way on each one, and because we customized it to meet the risk profile of the owner on each one, and yeah, I think it can work. It doesn't work all the time, we can make improvements, but definitely it's not stopping us doing things today.
And are you seeing any of these kind of trends, Panos, within your sort of organisation?
We have done trials, we had positive results, we had negative results, so it is not so easy to take decisions to move actually for the whole fleet to apply something. It is always depends on financial situation of the company, and also, as Hugh said, you need to have a partner that will agree that you have this kind of benefit, and that will be shown in the contract that you have with him, that he will appreciate that extra miles that you put in this ship.
But do you think that kind of system of the share of the upfront cost and the downstream benefit can become the norm in the future?
Of course, yes. This is, we have done that in the past. This is something that you share cost, you share also the exposure, you share also the risk of having technology that will not perform as expected. What the owners will take at the end, however, it is the maintenance cost that sometimes has big surprise behind. There are makers that are not so supportive in that they don't have the proper after-sale service, or they come with unreasonable costs for the routine maintenance part. So definitely you have to take this kind of risk, or to be prepared and to have a good contract from the initial discussion with the maker that will protect the company from this kind of attitude.
And in terms of the business case going beyond the ROI, in terms of the risk, what other information is being provided to support decision makers, Ariana?
Yeah, thank you for the question, John. And I want to say that I read the RightShip report on the adoption of the energy efficiency technologies, and a very interesting point is that adoption changes, shifts when the benefits are measured in a way that decision makers can trust. And that's exactly what we're doing. We're measuring the benefits by using industry-approved methodologies as per ITTC, ISO 19030, and in collaboration with reputable third-party institutes and universities. And that's what we use in order to provide data that are comprehensible and trusted by the decision makers. So, for example, for Sigma Glide, we have measured instant power improvement up to 20%. Which, of course, this is validated as well with high-frequency data. But something as well that is, of course, very important in order to scale up all these benefits, they need to be rewarded commercially. And this is where also charterers play an important role, and RightShip, of course.
And the same to Jess.
Yeah, so I think there's not a lack of willingness to invest, actually. There's a lack of belief that that investment will be rewarded for any energy-saving technology or hull coating. And there are industry standards. We were just talking about this in the lunch break, actually, of the ISO 19030. This standard came out, I think, like 15, 16 years ago. And it is a good standard for measuring hull performance. But it does have its drawbacks. There is no requirement for how much data is needed for validation of performance. So just an example, obviously we're a paint company, we design products, they start in a laboratory with a team of PhD scientists creating this, and then it's applied in perfect lab conditions. Doesn't represent real life in any way, shape or form. The only way to find out how that hull coating performs on the hull of a vessel for 60 months is to put it on the hull of a vessel for 60 months. But there's nothing stopping us going out and making a performance claim on day one. So it's very important that trust is brought back into these validations. And all of our performance data is validated by third parties. Otherwise, I think ship owners are just not believing the numbers that they're being given, basically.
So it feeds into the same thing that George was saying about the wind-assisted propulsion. It's the increase, the learning of data, the learning of what's happened over a period of time, and then feeding that in to sort of create a virtuous circle of investment. Which brings us on to the third theme in terms of how can ESTs scale further to support learnings that reduce cumulative emissions now and support the transition to a less energy-dense future. So we're currently dealing with one of the most notable combined fuel price increases and carbon cost environment shipping seen so far. And how is this impacting on how efficiency is prioritized within businesses? So if I throw that to you, Chris, first.
I'd say we already prioritized efficiency before, just because it makes business sense. And I think if you wait for something like now, like a price shock, it's too late. I think one of the other challenges is, like, if you look at the bunker price now, the curves are heavily backwardated. The market thinks that bunker price is going to revert soon. So you can't make a decision to invest in an ESD that you're not going to install for another year and it's going to pay back up 5 years just because of what's happening in the Gulf at the moment. So I think the way we look at it is we took some risks earlier, we made some decisions, some investments together with ship owners to upgrade ships, and now we're getting the return on that. So you've got to kind of make those decisions earlier on. I think the other thing I'd say is, going back to my point before of like hardware technologies and software, operational efficiency technologies. So this is where the operational efficiencies really kick in super fast, because we can, as soon as the oil price goes up, we can re-optimize our voyages to go slow steaming, you know, find the right voyages where it works and the ones where it doesn't work, and do that, you know, immediately. Yeah, that's our focus.
Throw that to you, Panos.
Look, actually, if we are wondering about the environmental impact, and if we are focused on the environment, I think that the best thing that we are expecting to see is actually a regulation that will put a limit on the emissions themselves and leave the shareholders actually to decide the way that they will comply with the regulation, with all this. So probably it will be an investment, but that will be investment on your ship. It will not be a kind of tax that you send money to somewhere that you will never know whether it will benefit the environment or not. So today there are technologies, and actually, if the target is the environment, we have actually to talk about the environment. If it is not the environment, but there are other reasons like taxation or promotion of other technologies, then we are focused only in one of the means for reduction, and then even the performance will be forgotten. For instance, if we are talking about alternative fuels and we promote the alternative fuels and we subsidize the alternative fuels, more you consume from alternative fuels, more money you receive. Then there is no meaning of try to perform better. Actually, more consumption, more money for your company. So I think that we must be focused on what is the target. If the target is the environment, we must be focused on the environmental benefits and only that.
But if the target is just the environment, what would be the incentive to sort of drive towards that target if it's not?
You don't have option, actually. If you have a regulation like we have ECA zones and SECA zones, you don't have the option. You like to burn or you don't like to burn the compliant fuel. You should burn the compliant fuel. If you have a limit that your voyage from Europe to the US has a maximum emission cap like that one, you don't have the option to go and to burn more. If your ship is efficient, of course you can go at any speed. If your ship is not efficient, then you have to think about alternative solutions or energy-saving device or alternative fuels if are available, or whatever solutions you have. But actually the target is that that voyage will be with a limited amount of emissions. So it's up to you how you will comply.
So purely a technical measure?
Purely, it's not technical, it's operational, it's financial, it's everything. But if you are focused just in one of the means, alternative fuels is one of the means. Energy-saving device is another. Operational measures is another. So if you are focused on what is your target, leave all the means to come, and the market will decide which means will be and until when. For instance, for energy-saving device and the present technology, you can go until 2040 in the targets of IMO. Definitely, you should start preparing something after 15 years. But at least you have the environment, the benefit of the environment for these 15 years.
Mm-hmm. And if we go to Jess and Ariana, are we seeing efficiency and energy-saving technologies move from just CapEx justification to operational risk management?
I think that would be the goal. I think there's still a lot of CapEx justification needed for all of the issues highlighted today so far. There needs to be more split incentive schemes. Because at the moment, I think there's a lot of burden put on the ship owner, and a lot of the benefit doesn't necessarily go to the ship owner. And let's be honest, we're businesses, we're not all NGOs. So you can't expect ship owners to do things just for the, the goodness of their hearts. And yes, everyone wants to improve the environment. Of course, that's a given. But it's how do we get there? So we need a lot more of these split incentive schemes. Otherwise, you're asking owners to invest, and invest heavily, on something that may have a return on investment if they avoid a serious incident. But if that incident doesn't happen, then they don't, what's guaranteed is they don't get that return on investment. So we need much clearer data and much better split incentive schemes. And then we'll see a lot more uptake.
And the same to Ariana.
Yeah, thank you. I agree with Jessica, but at the same time, we also see definitely a shift towards operational risk management. Because now with the IMO greenhouse gas regulations and the biofueling management plan, poor hull management is no longer an option. So we see our customers as well relying more and more on operational management via data. We support them with operational monitoring with our HALNAV service, which also provides proactive risk alerts for operational management so that they can be more proactive rather than reactive in managing their hull performance. So we definitely see this shift and these needs, and also this being part of our customers' operational risk management strategy.
Okay, and Vasilios, in terms of making the decision, what else needs to change to make realizing energy efficiency the norm in the industry? Is it technical uncertainty? Is it operational incentives? Is it something else? What needs to happen to get the long tail of the industry to sort of make this the norm?
I think possibly the biggest thing that needs to change is the whole mentality of trying to understand what's going on and to measure what happens on the vessel operationally and design speaking. And especially on the matter of measuring the effect on the vessel, we have a long way to get there. I mean, possibly 50% of the vessels don't even have serious torque meters, or they don't get data through telemetry. And even when they have the data, they do not know what to do with them. And of course, we are here to help our clients. But they need to understand that they need to have good quality on the data. They need to be precision-driven, not just in snapshots, but as constantly as they can. And that doesn't mean just telemetry. It means also maintaining your systems and calibrating them regularly, checking your flow meters, checking your torque meters, which in the end will end up to allow you to measure the effectiveness of our caps or the paint or whatever else they have installed on the vessel.
So it goes back to that data, giving the confidence in the technology to support the ROI decision and the investment decision.
I think that's the biggest one. There are also several other aspects like transparency on the ways they evaluate. Like, I mean, there are many ways to do CFD and many different kinds of quality that you could prove, or as Jessica already said, the lab and the reality are a big difference, so it's not enough to prove in the lab that a BCF works okay or a paint has low friction. You have to prove it in practice.
Yeah, Chris, have you got something?
Yeah, I just want to, I agree 100%, and I said at the beginning, like, data, so I agree with you, like, with everything you're saying, but, like, to play devil's advocate, I think, speaking personally as a naval architect and engineer, and a lot of us are, I think we have this habit of like going, okay, we need to understand how this technology performs to like 5 decimal places. And until I know that, I can't confidently invest in it. Like, we order ships and we don't know what the market's going to do for the 20 years that we have the ship. We put scrubbers on vessels when the regulations change. Someone, spoke about, Panos, you spoke about regulations as being a big driver. Look how quickly scrubbers scaled. We didn't know what the spreads were going to be in bunker prices to do that. So someone on the last panel said, don't let perfection be the enemy of good. I think sometimes you just got to go, I think this is in the right ballpark, and take some risk and just get on with it. Excellent.
So don't let perfection get in the way of progress. So we've got 2 minutes left. If we give everybody sort of 30 seconds, what needs to change up to 2030 to enable us to take action on those cumulative emissions? If I start with you, Vasilios.
Oh, me first. Okay, so I think we need to start to look more forward and add more also operational measures in the mix. If we are going with wind assistance, then we definitely need to check the way we do the routing and how the crew works with that.
Okay, Ariana.
For sustainability adoption, I think the benefit. I'm sorry. I think for the sustainability adoption, the benefits need to be rewarded by the charters, commercially rewarded by the regulations as well, by IMO subsidies, so that they can enable the faster adoption.
Yes, so similar actually. Benefits need to be rewarded and claims need to be proven, basically. I'm sorry, I'm aware the clock is counting down very quickly. But also I think events like this help as well. Everyone needs to agree, A, that there's a problem, and then we need to come together and do something about it. And I think fragmentation has come up a lot, actually. So I think, yeah, realising there's an issue is kind of the starting point.
Actually, you mentioned 2030. I think 2030 is too soon, and the results will be, we have already achieved very close to 2030 results today with the emissions, so it is not a difficult task. But what we need actually as an industry is better information. Unfortunately, the regulations that are drafted are difficult technically to understand. Many people is involved, but they don't actually understand what exactly the regulation is and what are the implications. So I think that we need better information, actually.
George?
Collaboration. We have to understand that ship owner is not the one only responsible for whatever happens on the ship. For the fuels is a very good example. If you don't supply fuels, nobody can burn them. And I think the example that Nick brought earlier, how you collaborate different stakeholders together with the ship owner, share cost as well as benefits. I think that should do the trick.
And finally, Chris.
Everything they said, I don't think, I'm just going to repeat what everyone said here, yeah.
Excellent. Well, that brings the end of this session. Thanks very much for your attention. If you'd like to just and we'll pass over.
Thank you.
Just get a photo.
No need to rush. You have time for a picture, don't worry.